go. What is that?
Array.
Array, okay. And suppose we put another one here.
Angle.
This is an angle, that's right. Okay, now what do you remember at angles? Let's see. What kind of an angle is this one?
Right angle.
It's right angle. What's its measure? Very good. Okay, what is this angle? It's acute. How do we find its measure?
If it's 90 or less.
Well, that's how we know that it's acute, but how do we find out what its measure is?
With a compass thing.
We use a protractor, just like this, okay?
I know.
Oh, yes, well, I have plenty, you don't have to get your own. Okay, now, what kind of an angle is this one? Why do you say that?
Because we already did a right angle.
Uh-huh.
We already did an acute angle. The next would probably be acute.
What about this one?
Ouch. Oh, whoa.
Ooh.
That would be straight, and so then you're right, we'd have to have an obtuse because it's the only other kind, right? Okay, so it would be like this. And that would be an obtuse angle. This measure is what? We know that it's how much? Not specifically, but what, Ellen? It's more than 90. Okay, what about that? What about that straight angle? What's its measurement? 180. Oh, good, you guys are really right on top. All right, so now, suppose we have this. We have that, and we have an angle here. This point we call A, we'll call this one B, we'll call this one C, and we'll call this one D. Okay, now there are two angles that we really are interested in here. One of them is angle ABC, ABC. And the other one is angle DBC, DBC. What do we know about those two angles together, Brennan?
That together they are after 180 degrees.
That's right, their sum is 180 degrees. And they have a special name. Do you know what that name is? They are called adjacent angles. They touch each other, they have a common sign. Okay, so that makes them adjacent. Now, adjacent angles do not have to add up to be 180. You can have this kind of a situation. And this we could call angle X, and this would be A, B, and C. All right? So we have angle AXB and angle BXC are adjacent angles. There's another pair of angles there, actually two more. One of them is angle AXC and BXC. They are not adjacent. Do you see why? My bad.
What about AXB? Is that one?
No, the ones that I'm talking about are AXC and BXC. They are not adjacent. Why would they not be adjacent? Thomas?
Do they not also do 180?
No, they don't have to add up to 180. Why not?
One of the ends doesn't touch to each other.
Well, yeah, and what's more, this one sits inside the other one, okay? So we would not call those adjacent angles. So we want to know some things about adjacent angles. Suppose this angle is 60 degrees. And this one is 15. The sum of angle, the measure, we will use that little m, angle AXB plus the measure of angle BXC is what? How'd you get it?
Because I added 60.
That's
75
right.
degrees.
We add 60 and 15 and get 75. Okay, so then let's assume this is the case. You did the easy case, now let's do this one. And this angle is 130 degrees. And this angle is 45. How big is angle NMO? And how can we find it? N, what do you think? All right, we subtract 45 from 130. So you would go 130 minus 45 equals what? Okay, I trust you, right?
That's what
Is that what you got too?
He's right.
Okay.
would the answer be NMO equals 85 degrees?
No, the answer would be yes, because this is what we're looking for, NMO. All right, now, angles are very interesting because they can have lots of names. You can have this angle right here. We have well, we'll make it an N because that's what I wrote. O and P. All right, now, one of these angles is called, one way to name this is angle O. Let's make it a Q because zeros are, they're not good. Angle Q. Another name for this thing would be angle NQP. A third way would be angle PQN. Any of those three would name this angle right here. So you want to be aware of that because sometimes you want to name them that way. It seems more sensible for you. It does not have to be this way, it can be this way, or it can be just the vertex alone, as long as it doesn't have an adjacent angle. All right, so now then we want to talk about measuring an angle. What to do? Thomas?
Does it matter which order it's in? Just the has
This Q has to be in the middle.
Okay.
The point, the vertex is called the vertex, and the vertex always has to be in the middle.
And what about like the angle Q? How is that? Why is it just staying on?
Why is this just Q?
No, you wrote it, the different names for the angles. We wrote angle Q.
Yeah, this could just be angle Q, because there is no other angle touching it. So we could just name this angle by its vertex, which would be Q. Okay? All right, now, let's suppose we are going to draw an angle. We like our angles to be as straight as possible, so we can use the edge of our protractor to make the lines, the rays, straight. And now, this is a problem I'm making up, and you know when I make them up, they are always fine. Real problem. Okay, this is angle A, B, C. And we want to measure angle ABC, and we're going to use a protractor. Now, when you deal with a protractor, there is a 0 point. In this protractor, it's right there. That has to be placed on the vertex of your angle. If you have one that looks like this, it's right here. Okay? Still has to be there. And then from there down out each direction, there's a line. So you're going to put that point on the vertex of your angle, and you're going to have one side of the line or the other be on one of these lines. Does it matter? No, but it does make a difference which part of the protractor you use. Angles start at 0, they don't start at 180. So if you were going to measure an angle like this one, by the way, there's lots of other kinds of protractors too. If we were going to measure this angle, we put the 0 point right on, you see it? And then there's a line here. You see these lines? Okay? They have to go right along the ray of the arrow. Now, since they start at 0, not 180, we have to start at 0. Where is the 0? Here or here? It's on the inside. You see what I'm saying? The 0 point is on the inside, so that's the side I'm going to read. Now, this particular kind of a protractor is really handy because it's got a little gizmo here that'll pull it over there and you can read how many degrees it is. We're reading the inside, so it looks to me like it's about 52 degrees. Alex?
What about the angles? The angles that have like the two arms, but then the trident at the outside.
Oh, on the outside? If you're trying to do that, that's called a reflex angle, like this. This is what the one you want. Then what you do is you measure this one and subtract it from 360. Because the whole thing is 360. So you just would measure that angle and then subtract it from 360. Okay, now let's see if this one measures the same. We put that there. Now this time we don't have that nice little pointer thing, so we have to carefully go along, but it still looks like it's 52 degrees. That's good. Those protractors are the same. That one lost its handy dandy little stick. Somebody broke it off. And that's that kind. Of course, then there are old-fashioned ones like that. And there are little ones like this. Okay? But regardless of what kind of a protractor you have to determine where is the 0 side, because they open from 0. They do not open from 180. Kayla?
So, like draw it on your paper, what different people get like different sizes?
Well, they may be off by a little bit, yes. Like if I said to you, draw a 60-degree angle, it might be off by a degree or two, but if you're using your protractor, it won't be. And let's look at how you would draw that if you were going to use a protractor. Say we were going to draw an angle, a really difficult, 41 degrees. Sure. We first draw one of the rays that we're going to be using. All right, and we're going to draw 41 degrees. So I have to find, this thing is so old. Okay, so then we want to go from up to 41 degrees. Here's 30, and here's approximately 41. And then we would draw this. Now, if you were going to be using, you were doing it, you might get 42 degrees and Emma might get 41 or 40, but you'd be close enough within the range of the width of your pencil and all those kinds of things. Okay? All right, now,